Hello again, everyone, and welcome back. You guys are the marathon runners who really have the stamina and the endurance as we get to the sort of 20-mile mark. You're not flagging. Congratulations. We are continuing our discussion, and by the way, those of you just making your way in, do come in and find a seat. This afternoon, we're going to continue with our theme of future Arctic business. We got some perspectives in a fascinating debate before lunch. We've got different takes, different businesses, different geographical locations, different perspectives on the potential for expansion of economy and business growth in the far north in this afternoon's panel. It's the same format, so I think it works quite well. I certainly am enjoying it. So we're going to have keynote speakers, and then we're going to have a panel discussion. And this time, I promise you, I'm going to make sure I leave lots of space for your questions. And we're going to shift the panel around halfway through to get more voices and more perspectives involved before the end of the session. So, as usual, my first job is to invite our keynote speakers to the stage. And first up this afternoon, give a warm welcome, if you would, to Nicolaus Hanowski, who is the head. Well, that's very keen, my goodness. I'm going to tell you who he is, and then you can clap. He's the head of, now he could do it himself, but anyway, I'm going to do it for him. Head of the Mission Management and Ground Segment Department. Some of you may not know what that means, so he's going to explain in just a moment, at the European Space Agency. So, Nicolaus, welcome.
Yeah, thank you very much, and it's a great privilege to be here. Maybe I start by explaining what the European Space Agency is. The European Space Agency is an intergovernmental organization, independent intergovernmental organization with 22 European member states. Canada is an associated member. And I think at this point in time, it's also important to state that Norway and the United Kingdom are members of ESA and will continue to be members of ESA. The European Space Agency has an annual budget of about 5 billion euros distributed over various programs. I'm representing here the Earth observation program, which is by far the largest program of the European Space Agency. Our annual budget is about 1.6 billion euros. And a lot of this budget goes into activities that are directly relevant to the things that are being discussed here. I'm happy to be in a position today that I wouldn't have been 5 years ago to make the statement that Europe is in charge of the largest Earth observation infrastructure in space. This is largely the result of a close cooperation of the European Space Agency with the European Union, but also many other partners. And together with the activities in our member states, we at the European Space Agency have actually developed a space infrastructure, meaning satellites that are measuring on a global scale, on a very operational level, with very different technologies, with radar, with optical, microwave, the conditions and the physical and chemical parameters that are relevant in the discussion here. The plans, together with the European Union, is to expand this infrastructure. The Copernicus program is the most visible part of this program. And we have an estimate of an investment in the future in the range of another 8 billion that we would like to spend together with the European Union on the further evolution of this infrastructure. Let me also say that there were 3 paradigm shifts in Earth observation and in the context of what we are discussing here over the last few years. The first one is that we have a free and open data policy. Everything that I'm referring to here is accessible in terms of the data that is coming out of the system. The second paradigm shift is that the challenges in the domain of big data are the key challenges that we are facing today. In terms of the instrumentation, the sensitivity, the sophistication of the instrumentation in space, we are very, very much advanced, and we are on a good path into the future. The key challenge is to be able to manage the data volumes, the data diversity that is coming from these systems, and to make sure that we are able to extract the right information, not only for science, it's ever more increasingly also for commercial application, operational services that are so key in the commercial evolution, the business evolution also in the Arctic. The final emphasis or the paradigm shift that I wanted to address is really the fact that we see a strong shift in Earth observation from science into the business domain itself. One of the key ambitions with all these systems and the interaction of these systems is really to provide the information, to provide the data in order to start new business, to evolve, to develop the existing business models further, in terms of providing information about infrastructure, resources, traffic management, pollution, human footprint, and related things. From an ESA perspective, very quick, 4 elements in which we see our role and our interests. First of all, monitoring and understanding the changes, the evolution in the Arctic domain, again with the full range of instrumentation that our systems are providing. A strong link between the changes that we see in the Arctic and climate change has been discussed quite a number of times. But with our system, we are quite capable to also assess changes in terms of pollution, resources, traffic management, and again, the general impact that activities in the Arctic are generating and providing the planning base for further activities. The second aspect is contributing to the overall infrastructure that is developing, and here I need to expand the view beyond Earth observation also from an European Space Agency perspective, because communication, navigation are strong pillars of that infrastructure as well. And again, the space component for which ESA feels responsible is a strong element. The third element is utilizing the Arctic as an infrastructure element for our purposes, and I can say that in particular the data acquisition stations in the polar regions, in the Arctic regions, are key for us to collect the data for simple physical reasons that our satellites are polar orbiting satellites, and the best way to retrieve the data from the satellites is by placing the ground stations in the Arctic regions, and key ground stations are in the Arctic. The final element that I would like to stress is related to the paradigm shift of the big data angle. To facilitate interactions between science, the institutional demands, needs, services, operational services in order to have an operational infrastructure in the Arctic available. The industrial needs in particular, what do companies need in terms of data sets, in terms of information from these data sets in order to develop their business in a sustainable way. And last but not least, also the political and programmatic aspect. These coordination and these interactions are the key domain in which the European Space Agency is active. Let me finally state that the European Union just concluded a competitive council in November last year, and a key recommendation that came out of this council was that the space solutions for sustainable Arctic development should be a key task for the relevant entities in Europe, the European Union in particular, European Space Agency, also EUMETSAT, for example, to work together in order to harness the corresponding resources. Let me make a quick comment in terms of references here. There's a side event planned for 1700 today, which will introduce you to the Copernicus Maritime Service, which I think is a good opportunity to give you a bit more practical insight what I'm trying to convey here in a more theoretical way. Thank you very much.